Hello everyone, I'm going to introduce the week 7 lab for you. And I'm the TA. So let's do question 1. How to use the arguments and keyword arguments in Python. And I'm going to open the online GPT tool for you. So we first paste the copy and paste the example input and expected output. So to get this output, we have two solutions. The first one is keyword argument. Now let's define this function as okay. Now this function can accept keyword arguments. Essentially, it's a mapping between the key and value. So we can just get the key using it. Okay. Once we have input this title key, so we can get the result of the title. It's Titanic. And we can see the temporary result. Print. And run it. It shows that the title is Titanic and we are getting the right answer. We can simply adopt this mechanism to other keywords. And I'm going to just paste this code. And run again. As you can see, we have got the result. So next thing is we want to print the movie details using arguments. So we need to change the input as what we want it to print. In this case, we want it to print the following words. The title, the director, and the year. Now we have input 3 keywords. 3 arguments without keywords. And we should write the function define print movies argument. And since it's a list, we should iterate over all arguments. So I'll write a loop. And run again. Oh, oops, I lose a and this time we don't use the first function. And for your reference, we can get the result. So as you can see, we have finished the use of arguments and keyword arguments. Now let's go to the question number 2. It's about differentiate the local and global variables. It's very common in Python to use local variables and global variables, and you need to remember what you are using. So similar to question 1, we will copy and paste the example input and output. Okay. First, you need to understand where the local and global variables lies in, and I'm going to see. I'm going to write the global variable first. It's 8.5, so it's a global variable now. And I'm going to introduce the local variable inside this function. Now we define a variable with the same name, but a different value, and print it to see if we are referencing the right value. And we print the global value first. So the function will first execute this line, the line 13, and then it is execute the line 19, and we can see the result. The global rating is 8.5. And we will call this modify rating function, and we can see the local rating is 9. After the local rating has been changed, let's see again if the global rating has been changed or not. So you can see that after the modify rating be called, local rating is 9, but the global rating is not changed. And here we can understand that the rating inside this function is not the rating outside of this function. Let's go to the question number 3. It's about how to use return statement in the moving age. The scenario is about moving age, but we're going to use this just like the question before. We'll copy and paste the input and output. Sample input. Now let's get back to this question. How to use the return function of the Python. The return statement. We need to get the result of a function. So let's define a function. And the current year in this scenario is 2024, of course. Oh, sorry. In this scenario, it should be 2023. And we want to calculate how many years between the current year and the release year. So we should get the result. It's just the release year minus current year. But the question is, how can we pass the result to the main function? I mean, main state. Now let's call this function print the result h. So all we need to do is here return result, and the arguments equals, or the value of the h will be set to be the result, and we print the h. It's minus 9 year, of course, because the current year is 2023. Now change the release year 2024 and see the h is 1. This proves that we got the right answer. Okay, now let's go to the question 4. The question 4 is about countdown. Countdown the year until the release year. So just like before, copy and paste the example input and example output. This time we will use the recursion. So what is recursion? I think it's a typo here. It should not be recursion. It's condition instead. In other words, we will use the if-else statement to deal with this condition statement. And we will continue to this example input and output. So function is called like this, and we will write define as current year and next release year. So to understand, there are two conditions, and to deal with the different condition, we use the if-else. If current year is less than next, then what we can see, then we can calculate the years left. After calculating the left years, we can determine the correct suffix for the year. In other words, year or years. The suffix is as if years left is bigger than 1. And now we have used 2 times if else. And finally, we can construct the message and print it out. And we have dealt with the condition 1. If the current year is less than next release year, but else, if it's equal or it's bigger than the next release year, then we know that it has been released. So we cannot count down. We just print out the message. It's been released, and that's enough. And finally, we can print the message. And now let's run it to show the result. 1 year until the next. So it proves that the if condition is set right. And if I change this to 2024 and run it again, it says it has already been released. So it's correct. Of course, if I change it to 2025, it still hasn't been released. Now we have tested the 2 conditions, so the program is written. It's written correctly. Let's go back to the question. Question number 5. Question number 5 is about nested loops. We want to make it print out the following output. There are 9 spells, and each spell has a different vacancy index. The spell index, and there are 3 times of casts. So we will use the netted loops to loop over the 9 statements and print them out. Now let's, of course, we'll copy and paste the example input and output. Spell. Okay, these are our outputs. The input is spell and without any input arguments. So we just write this function print. So we should define how many loops we should get. And there are 3 spells and 3 casts. Number of 3. Next, we can just loop through all together. The first loop is through the expeller, right? So we just call it spells. First is loop through spells, or spell index in range. And now we can get the spell index 1, 2, 3. And using the previous node condition statement, if the spell index equals 1, spell name is expeller, and there are other conditions. We can use else if. else if it equals 2, then the spell name. And finally, there are only one spell left. We can just use else. Spell name equals what? Now, since we have got the spell name, we can do the second loop through casts. And now when we use a nested for loop inside the outside for loop, and we can get the cast count in range of 1, 2, 3, and it's just a repetition of print. Using we previously defined spell name and cast count. So the program is finished, and let's test. You can see the expected output is just the same as the output. We can now this is the first implementation. We can make it more simple, or to make it simpler, we re-implement this function using a list. First, we define the spells as a list. Just using for loop for these spells. For and we can get the cast count. Finally, we can print out the result. So the two implementations. The second is, of course, simpler, but we can change it to more simple. Now let's comment this implementation, and this time, do we really need to iterate over the cast count? I think not, right? The cast count is 3 times. You can make your own choice. And like the spells, write a casts, and it's 1, 2, 3. And for cast count in casts, so we don't need to iterate. We don't need to use the range, and we can just get the answer, and the logic seems simpler, and the result is the same. Now we have finished this question. Let's go to the question 6. Finally, let's go to the last question. We will use the knowledge we have learned today and to implement this function. It can accept the three kind of dinosaurs and make the following function. First, print out the species with its numbers and calculate the total number. This is more difficult, and the most difficult is to count the number of species with more than 4 individuals. So there are two functions. There are two harder functions that we need to implement, and there are notes that you can use the global variable and the recursion, and finally print out them using formatted output. Of course, we should copy and paste the example input and output. For input, calculate, and for output, species, total number of species. So first, the example input is put here. Now, as you can see, the input follows the keyword arguments format. So we will define this function to accept keyword arguments, right? So first, we should just print out the number of each species. Get the final source. Let's have a check. So this function runs right, and we can copy and paste the other functions. First one is dinosaur, and the second one velociraptor. Called keyword argument it. This is a more advanced implementation, and I will discuss this after we have discussed the method 1. So let's go back. First, we should implement the function with a simple and basic argument. Now let's change the input first. It should be simpler. The input is like this. We just give the count and input the arguments directly to the function. And now let's write the function. It accepts 3 arguments and print them. Now without hesitation, we have printed out the 3 arguments. And next, we should accumulate the total dinosaurs. Total count just equals to the 3 count. We need to return the total number of dinosaurs to make sure that when it is called, the total dinosaurs will be set to the right number. And we need to implement another function because we want to print out more than the total number, and there are a number of species with more than 4 individuals that we should count. So to count this, we need to define a new function. It's called count species with minimum count. The minimum count is 4 in this case, and it also accepts the other 3 arguments. Now this time we should calculate the species count and check. Check each species. If it's more than the minimum count, then the species count can be added with 1. Others are the same. If count more than minimum count, species count if count more than minimum count, then the species count got the species count, and we can just print it out, or we can return. Now we have returned the result and just assign it Now let's get the total dinosaurs and species count. After doing this, we can finally print out the result. Oops, there's a mistake. Local variable. Total dinosaurs. The total dinosaurs should be a global variable because we need to count the global dinosaurs equals 0, and we want to change the global dinosaurs, so we have to state that we are using it. So here is the global dinosaurs, and we run it again. It's not defined. Oh, okay, I see. Total dinosaurs. Species count. Species about 4. Total dinosaurs is 16. Just delete this. Anyway, the total dinosaurs is a global variable, so we don't need the return because it's globally accessed and changed. As a result, the total dinosaurs still the same result. We don't have to make it return and print out. Anyway, the method 1 has been implemented. Now let's get to the method 2. Okay. Just for your reference, I have moved the method 1 cut, and now let's go to method 2. Make sure you have make a screenshot of the method 1. Now we can get the same result using method 2 here. Next time we will use the dictionaries. Of course, there is a total dinosaurs global variable. We can calculate dinosaurs. And we state that we are using the total dinosaurs of global variable. So we accept the keyword arguments. And the example input is a dictionary. So we don't. So we can use this function, and we can also use the dictionary function as input. The latter one seems more beautiful. So, and we can formulate the output. Just use the for iteration through each one. For species, count, keyword items, print, and add. And we should get the result. So you can see These 6 lines of code get the same result as the following 2 lines of code. So we just delete them and run it again. And we have get the species. Now let's continue to the next function. Of course, since the total dinosaurs is changed, we can access it just with the following code. Print total dinosaurs. It's a global variable. We don't have to assign another local variable. And the next function we should implement is the count. Count species with more than 4 individual species. So we should implement this function. Define. It accepts dinosaur count. So it's in the minimum count and species count. Similar to the above function, we just iterate over all the first, we get the first item, the key arguments item. It's a collection of species with its count. And before that, we should check if there are any questions with the input. The keyword arguments input may not be a keyword arguments input because there could be nothing or no more species to check. And should count if the count is more than 4. In this case, it's 4. Then the species count should plus 1. And finally, we can remove the checked species called filters keywords. This function is based on recursion. Recursion means that the function will call itself in the return statement. So the return statement will return itself. The function will call itself with the changed keywords arguments. And this time, the species count is also passed. The minimum count is the same. So this function will call itself until there is no keyword arguments. So all dinosaurs are counted, and it just returns the species count it has counted. Now with this recursion function, we can get the species above 4 and print them out. let's check if this runs correctly. It's more than 218. The minimum count is int, so count is a tube y. Of course, there is a problem, and debug this. Okay, sorry that I have lost lost this white. We should get the keyword arguments, species and count from the keyword arguments. And this time we will decide if the species count can add 1. And after this, we can filter it out. So the filtered keywords arguments will filter this key if it's equal to the species. I mean, it has been processed by this function and will filter it out. And we pass the filtered keywords arguments to the next if self function. And this time we run it again. We got the right answer. The number of species with more than 4 individuals is 2. This is the recursion function. Note that you should write these lines of code and to determine when the recursion function should exit, or there will be a stack error. And this time, and the fact of recursion function is that it will return itself with an updated arguments. If the arguments are not updated, then it will cause stack error. So be careful of this. We can comment the exit condition and to see what's the error. Stop iteration. Well, so we can see that it has been called 4 times, but there are only 3 types of dinosaurs. Anyway, and the species count cannot iterate to the next. So it means that all dinosaurs are being counted. So the function should exit. Now let's get back to the right one and run it again. So it's the right answer. Thank you for your listening. There are all questions.